Hi everyone, welcome to my channel Chemistry Tutorials by Kiranmay. In this video, I am discussing about Introduction to Quantum Mechanical Model of Atom. Earlier, we discussed about few developments that led to Bohr's atomic model, and later on we discussed about the further developments which are the basis of quantum mechanical model of atom. At first, we said that Max Planck quantized energy. He said that energy was quantized. Later on, the scientific developments proved that the electromagnetic radiations have dual nature. That is, the electromagnetic radiations have both wave nature and particle nature. And then de Broglie extended these dual nature to matter. Dual nature to matter. So he said that matter also have a wave-like nature and it also exhibits particle-like nature. So when he said the matter will behave as a wave, he also gave a mathematical equation to calculate the wavelength of matter. That is, the wavelength lambda is equal to h by mv. Here h is Planck's constant, m is mass of an object, v is its velocity, and wavelength is given by the symbol lambda. So according to this formula, we can see that for macroscopic particles, or objects, the mass value is more. So automatically, if we calculate the wavelength, the value of wavelength will be very small. Very small. See, if the value in denominator gets on increasing, then the resultant answer will be less. For example, if we consider 1 by 10 and 1 by 2, let us consider these two fractions. 1 by 10 means the answer is 0.1. 1 by 2 means its answer is 0.5. 0.5 is greater number. 0.1 is less than 0.5. Means as the denominator value increases, the resultant answer what we are getting will be less. When we take a denominator which one have less value, then comparatively we'll get the resultant answer bigger value. Similarly, if the mass value is more, then the resultant answer lambda wavelength will be very small. So this is a wave. If its wavelength decreases, so distance between two successive crusts or troughs is considered as wavelength. If this wavelength value decreases, then the waves become very small, at times like this, very small. When it becomes further less, we cannot observe wave. So for macroscopic objects, we cannot calculate the wavelength, which will be very small, and we cannot observe that wave nature. Whereas for microscopic particles such as electrons, the mass will be less. So automatically the resultant wavelength will be more. When the wavelength is more, we can observe the wave-like properties of electron. So de Broglie said that as matter exists in dual nature, as matter has dual nature, that is wave nature and particle nature, so as the electron have wave nature and also particle nature. He said that electrons behaves as a standing wave. Let me show one image. You can see one standing wave image. This is an example of standing wave. It will be moving up and down, but it will not move from its place and move to another place. This type of wave is known as standing wave. In fact, he said that electron behaves as a circular standing wave, like this. Circular standing wave. Circular standing wave. So, if we consider this as a short one wave, one trough and one crust, and another wave, one trough, one crust. Circular standing wave means I am showing 1, 2, 3 waves. This is the third wave. The ending of third wave must be the starting of first wave. Crust, trough, crust, trough, crust, trough, crust, trough, crust, and then trough. See, this is 1, 2, 3 and 4, 5. Fifth wave ending will be the starting of first wave. If this will be the circular standing wave, then there will be no superimposition and the wave exists. So suppose if the 1, 2, 3, 4, 5, 6, sixth wave starting is here like this, but this ending is not overlapping with the starting of the first wave, then it will not give a standing wave. Further, this wave interrupts with the other wave and then the standing wave doesn't occur. So, if we consider electron as a circular standing wave, then only the integer number of waves will result in the orbit. For suppose if we take only one wave, this is crust and this is trough, the ending of this will be starting of this. And if we consider another one, crust, trough, crust, trough, crust, trough, n equal to 3. So there will be only n equal to 1, n equal to 2. Suppose 1, 2, 3, 4. Like that. Integer number. Means here orbitals are also quantized. Even according to Bohr, though he considered the electron revolve in a concentric circles. He also said that energy is quantized. Each particular orbit will have a particular energy level. This is because each orbit n equal to 1, n equal to 2, n equal to 3. There will not be in between these two orbits, there will not be another orbit which have the energy of 1.5 or 1.2 like that. It is an integral number. So here also we are considering it as an electron standing wave. It is only possible when the wave number is integer. So this is an important step to understand the structure of an atom according to Bohr's theory. So for somewhat Bohr's theory will be holds good when we consider the electron as a circular standing wave. So this one, and that is considering the matter having the dual character, particularly considering electron as a standing wave, and then Heisenberg's uncertainty principle. Heisenberg uncertainty principle. According to Heisenberg uncertainty principle, electrons' position and momentum cannot be calculated simultaneously at the same time. If we calculate exact position of an electron, we cannot calculate the momentum at that time precisely. And if we calculate the momentum correctly or accurately, then we cannot accurately calculate the position of the electron at that moment. So we cannot calculate both at the same time. He also gave the formula delta x into delta v is greater than or equal to h by 4 pi m. Here delta x is uncertainty in position, delta v is uncertainty in momentum. And then third one, Schrödinger wave equation. According to Schrödinger wave equation, h cap psi is equal to E psi. H cap is a Hamiltonian operator. It is a mathematical operator. Psi is wave function. E is total energy. So here total energy means the energy within the atom, what is its potential energy, kinetic energy, forces acting on it, that is the force of attraction between the nucleus and electron, forces of repulsion between two electrons. So these are all totally gives the total energy of an atom. And from the solution of this equation, he also gave quantum numbers. Quantum numbers such as principal quantum number, asymptotal quantum number, magnetic quantum number, spin quantum number, like that. These quantum numbers are generally used to describe the characteristics of electrons. And it also gives about the information about the electrons. Exactly, we can say that it gives about the these or quantum numbers gives the address of electron, means how the electrons are present within the atom. This information are all given by the quantum numbers. So in the following videos we discuss about what are these quantum numbers, what are the information the quantum numbers gives us about the electrons, how the atomic orbitals are present, means what is the shape of atomic orbitals, energies of these atomic orbitals, how these orbitals are filled, how the atom gets its stability through the filling of atomic orbitals and all we'll discuss in the upcoming videos. So these quantum mechanical model what we'll be discussing in further videos is mostly based on probability rather than certainty. So here the quantum mechanical model is mainly based on probability. It will not say the electron is present exactly here in this position. It will be like this, like that. It will not give a statement. Rather, it will give the probability. Maybe the electron will be present here. 90% the electron's chances present in this region, and it will not give the certainty. So, earlier, while discussing about the structure of an atom, scientists said that electrons are present in circular path. Electrons are like seeds in the watermelon, like that they gave exact position of the electrons. But in quantum mechanical model, the scientists will not give certainty about the electrons, rather they give about the probability, 90% probability of an electron where it is present around the nucleus and all. So this is the introduction of quantum mechanical model of an atom. Hope you understood this video. Thank you for watching and share it with your friends.